Hi again. This is Violeta Illich. I'm Dean of University Libraries at Adelphi University in Garden City, New York. I'm here to welcome you to the plenary session of the Day 2 Open Science Fair, Fostering Local and Global Open Science Communities. Today, we have on the program the following. Now we are at the point where we are looking forward to welcome our second keynote speaker, Dr. Sharan. She will speak on can we reimagine FAIR for building communities in open science? And then we will continue with the panel, opening artificial intelligence, the next open science frontier. We will then move into separate Zoom sessions for each of the workshops that you wish to, those links are posted on the website. And then we'll finish with the demos batch 2. All of that information is on the website. So now it is my great pleasure to welcome Dr. Malvika Sharan. She is the community lead of the Turing Way project at the Alan Turing Institute, that is an open source community and a guide for reproducible and collaborative data science. She involves and supports a diverse community of contributors, helping them adopt best practices in the research and collaborate within the Turing Way. She's also a co-founder of Open Life Science, a mentoring and training program that empowers researchers to integrate open science in the context of their communities. She's a Software Sustainability Institute Fellow, Open Bioinformatics Foundation board member, and an active contributor for open source community projects. We are extremely glad that she accepted our invitation to join us for this Open Science Fair 2021. After Dr. Sharan talk, we will go into the panel, Opening Artificial Intelligence, the next Open Science Frontier. Your moderator will be Dr. Yanis Ioannidis. He will introduce the panelists further. I just wanna remind you of a few virtual meeting housekeeping important notes. Submit your questions in the Q&A. The host, me, and some of the panelists can either reply back to you via text in the Q&A window or answer the question live. You can also virtually raise your hand to ask a question or a comment. And you can use the webinar chat to introduce yourself to the other attendees, to the host, to the panelists. Send a chat message to the host, panelists, and other attendees. In addition, please also keep in mind that this event is recorded. All participants' microphones are off. Presentations will be posted on the Open Science Fair website and Zenodo, and recordings will be made available on the Open Science Fair YouTube channel and Zenodo. You can follow on Twitter. The hashtag is OSFair 2021. And you can also follow the Twitter handle, post your impressions, your reflections, and your thoughts on the sessions you are participating in. And last but not least, we would like to underline that we expect all attendees, speakers, partners, and all the members from the organizing committee to adhere to the Open Science Fair Code of Conduct throughout the entire event. Thank you very much. This is the third Open Science Fair, the international event for all topics related to open science. So let's get started with Dr. Malvika Sharan. I'll stop sharing my screen so she can share her slides, and we'll go from there.
Thank you, Violeta, and the organizing committee. I'm going to share my screen and wait for a thumbs up from you that you see everything. Looks good?
It's all good. Yeah.
Great. Thanks again, Violeta and the organizing committee. This is an absolute honor for me to have the opportunity to speak at the Open Science Fair. I'm joining from a rural part of Ireland with limited connectivity, so forgive me if there are some internet issues. Today, I will share what I have been reflecting on for years, but did not before shared with the wider community. This is still raw and has a lot of room for further reflections and improvements. With that disclaimer, let me get started with this talk with a rhetorical question. Can we reimagine FAIR for building communities in open science? I was raised in a small town in Jharkhand, situated in the north part of India. Amidst the diversity of languages, festivals, and culture, most of my memory involves people. Extended family, neighbors, and communities were an integral part of everyone's life. An important aspect of such community-oriented life was that people always showed up for each other, listened to different perspectives, negotiated to find ways to align diverging ideas, and despite differences, they worked it out. Like many, I grew up in a low-income household, and fortunately among people who cared for the community they were a part of. As neighbors and friends, they cared for each other, shared what they personally owned, from basic things like fruits from their garden to tools when they needed them, to access to water when their well ran dry. Despite challenges and struggles in their own lives, people made sure that their neighbors had enough to get by. As I moved around in India and Europe as a student, researcher, and an immigrant, I carried with me that experience and understanding of what it means to be part of a community. Today, as I share my story with you as a community builder, it is important for me to acknowledge where I come from, how my experiences have shaped my understanding of communities, and influenced how I approach community management and participation. But my experience of community is not unique. Most of you have been part of a community in some form. I believe that each of you know how powerful that feeling of inclusion and belonging in communities can be. In families or neighborhood, or in classroom or workplaces, each of you must have experienced what it means to be a part of something bigger than us. I think this phrase perfectly captures that sense of community. This is the place where I stand on the day when my feet are sore. To define community for everyone, community is a social unit of people who share common values and mission. Though I didn't always call myself community facilitator or manager, what fascinated me the most in research was connecting with people and connecting people with each other based on their common interests and goal in open science. Since I have now developed vocabulary and references to define my work in professional platforms like this, I discuss community building through two concepts. Community of practice. It is a social unit of people who share common values and mission, where people gain knowledge, expertise, or benefit in some ways through informal interaction. And second is open science. It is a way of conducting research where everyone can access, reuse, build upon, and distribute resources freely without any barriers. Now putting them together, open science communities use open science practices for collaboration, peer production, and sustainability of research objects that are beneficial for them. Aim is to ensure active participation in the development and decision-making process of the research they use. This means that diverse contributors are given opportunities to come into the project with different perspectives, participate in the development process, and integrate their combined values in the product by design. Let me remind, open science is an umbrella term used to talk about multiple concepts and streams of practices like software, data, publication, education, processes. Open science communities are built around one or combination of these streams, where each community builds and cares for resources that are meaningful for them based on their context. My work as a community developer is highly influenced by the work of Dr. Leslie Chan and his colleagues at Open Science Community Development. As they put it, openness is not a binary condition, but highly situational, contingent, and dependent on the privilege and context of knowledge makers and gatekeepers. Individuals come together and collaborate to share tools such as hardware or software, infrastructure and skills, and even social change they want to see. Choices and actions they take are affected by their observations, needs, and resources available to them, and hence highly contextual. In this process, the role of open science should be in creating a global infrastructure that enables equitable access, participation, and decision-making process for all its contributors. And it should be grounded within ethical and existing human rights framework. Despite the diverse set of goals and challenges we all have and we all want to address in open science communities, we all share the common mission of making scientific knowledge freely available for public access. Open science communities aim at producing public good like publication, tools, practices, encourage greater collaboration among scientists from different disciplines, and broaden the diversity of science-producing actors. To emphasize on this commonality, FAIR guiding principles in this context can be used as a helpful tool. FAIR stands for findable, accessible, interoperable, and reusable. These are used in the data management and stewardship. They have also been applied to different digital assets like software and training material. Please note that FAIR is not a set of rules or standards against which we should arbitrarily measure the importance or quality of a research object. FAIR is also not the same as unregulated. Instead, we should use them to focus on some concrete action points that ensure that research we build are found by others, used and built upon by them for their work. With that, I invite you to reimagine if FAIR principles can be applied to community building in open science. Respecting the needs for diversity of people, ideas, and products across different communities, FAIR can be valuable for designing, supporting, and interconnecting community-led efforts. It is not a substitute for open or the nuances associated with context-specific open science. Through FAIR, I believe that we can create inclusive pathways by ensuring the communities we build are discoverable and accessible for participation. Furthermore, by encouraging collaboration between different communities, we can build sustainable open science ecosystem, allowing interoperability and reusability of common resources. So I should remind you that I want to use interconnection instead of interoperability to avoid confusing you if you have a set definition of what interoperability means. To state it more clearly, I'm exploring FAIR as establishing processes to make open science communities findable, ensure accessibility of resources and participation process, interconnect communities through intentional collaboration, and ensure reusability of resources through coordinated efforts. With this background on community, open science, and FAIR, and how they might be connected, I want to take the opportunity to share about communities and community building through my lens. I, like many of you, have been participating in several open science communities. As a graduate student, encouraged by my supervisor, I started by engaging with Bioinformatics Open Source Conference hosted by Open Bioinformatics Foundation. This gave me the first taste of what the willingness to share knowledge and space within an inclusive community can mean to a young researcher like me back then. Then I discovered software carpentry in 2015, where the kind approach to teaching programming made me feel more confident about my own computational skill to enable effective and reproducible work for my colleagues beyond my project. Several of such interactions led me to take community development roles where I could ask questions such as, who is in my community? Who else could be brought in? How they can be involved and how will they benefit from their participation? Fortunately, as my first job as a community manager at the European Molecular Biology Laboratory in Germany, my colleagues were interested in discussing these questions with me. They were enthusiastic about open science, open ways of working, and applying inclusive approaches to training and capacity building effort. My role as a community and training coordinator at EMBL BioIT allowed me to participate in communities of overlapping goals and mission at the institute level, at national level, and international level. I implemented community building strategies from local level in Heidelberg through BioIT to national level at DENBI, which is German Network for Bioinformatics Infrastructure, followed by international level in Elixir. I was also fostering and engaging with local grassroots communities and contributing massively to the carpentries as a volunteer. First of all, separating those roles in their isolated boxes was not sustainable for me. And second, our organization and local members benefited from such collaboration. Therefore, I started to think more strategically about sustainable engagement and scaling of community efforts by interconnecting individually operating communities. With different community leaders, we connected and aligned our activities by making institutional opportunities openly available, exchanged resources for reuse, and shared lessons of success and failure more rapidly and transparently across different communities. Through coordinated efforts between siloed groups of people, we were able to create more pathways for our community members to build skills, to reuse resources, and make effective use of national and international open source infrastructure. This is not a novel way of working, but this is where we can see a glimpse of what fair community building in practice would look like. Since then, in all my community involvement, I consistently explore if collaboration across communities and interconnection of their resources can be established. And could such interconnection enable sustainable development, maintenance, and reuse of resources? Before I go to the next part, I think it is useful to understand why context of knowledge maker and users matter. At the time, the scientific resources, standards, and practices that we were using were largely produced in Western countries and didn't explore alternatives by default. Working with international colleagues, I became more aware that there is a disconnect between the research practices as well as narratives between Western communities and Global South that included Asia, Africa, and Latin America. You can see in this map from 2016, visualizing a shrunken representation of publication from Global South. As the author Juan Pablo Alperin puts it, access is not only about being able to read, but being able to have a voice that shaped the direction of discipline. A simple example is that curriculum developed by one community with most members from Western communities was not directly applicable to another part of the world if we did not put them in their local context. Only through opportunities to teach with local educators in India, Argentina, and South Africa, I learned to challenge what we were teaching and how we could manage better participation in the local context. Simple changes to content, collaborative methods, and local language, when possible, made a huge difference in people's learning process. So even though open science resources are developed online, where everyone can, in theory, find, access, and contribute to them, it doesn't take away the fact that there is a barrier to participation online. Even those who participate aren't always involved in the decision-making or designing of the research output without massive redevelopment that might be required. And hence this perpetuates the cycle of more publication of resources from the global north than the global south. Since then, in all my community involvement, I consistently explore if collaboration across these communities can be established. Scientists are told to collaborate across discipline to contribute to interconnected stock of knowledge needed for scientific advancement. But in practice, it is highly costly to combine all those separate elements to produce useful solutions. Therefore, most of the grassroots initiatives operate independently while struggling to meet the needs in their individual communities. They either lack capacity to build meaningful collaboration with other communities or have no option but to compete for limited resources such as funding, volunteer membership contribution, and infrastructure. There is a disconnect between open source or open research locally and open research in international level. There aren't much incentive to use someone else's work when only innovation is being rewarded. So I also question if such interconnection could enable sustainable development, maintenance, and reuse of resources. As I explored these questions and aspects of community, I was working in the intersection of community building, biocomputation, and inclusion of historically underrepresented groups in STEM, for which I received a fellowship from the Software Sustainability Institute. Each fellow needed to find a mentor for their fellowship period, for which I reached out to Kirsty Whitaker. Kirsty openly spoke about open science, inclusion, and collaboration in academia. For instance, this is an excerpt from her recent article, where she says that a very narrow demography of researchers have the institutional support to spend time on open projects, as well as the fortune to be publicly acknowledged for their hard work. So she was working in the similar space as me, except that I had never collaborated with her. So this was an exciting opportunity to learn about her work, which included the Turing Way. This brings me to the first project, the Turing Way. Started by Kirsty, now I am the community manager of this project. The Turing Way is an open source, open collaboration, and community developed book on data science. We involve and support a diverse community in making data science reproducible, ethical, and collaborative for everyone. It is a part of the Alan Turing Institute, which is the National Institute for Data Science and Artificial Intelligence in the UK. It was started as a book on reproducibility by Kirsty, with the involvement of a group of open researchers who documented recommendations for reproducibility tools and concepts in chapters. Shared as a lightly opinionated guide, the Turing Way aimed to ensure that the researchers, funders, policymakers, and all different stakeholders in research know what their responsibility of reproducibility is, where they can make an impact, and how they can make their work more efficient and understandable. One of the members from that initial team, Rachel Ainsworth, demonstrated the book for the first time internationally in 2019 at the Open Science Fair. And later today, she, along with two of our core members, Emma Caron and Esther Plump, will be running a workshop featuring the guide for research collaboration. So please join them if you can. Starting with the definition, the Turing Way defines reproducibility as when same analysis is applied to same data, it should give same result. There are other concepts around reproducibility like replicability, robustness, and generalizability. However, reproducibility in biocomputation or computation analysis should be maintained as a minimum criteria to ensure quality and integrity of our research. Reproducibility starts right when you have a research idea. You want to communicate it to others, plan and design your work. Then you want to describe your protocol and collect data. You start processing and wrangling your data, conducting your research, and then you start to publish so that others can access what you're working on. Then comes the archiving that can ensure that your data is reusable, meaning that someone else can go through this whole process of reproducing or building upon your work. However, this is not enough. As scientists, we also have a duty to ensure that our work meets the highest scientific, ethical, and moral integrity, especially when it impacts people's life. This impact on life can be through the process we establish in conducting the research, data we collect and use, or through the data products we build for others. It can also be through the policies that we follow at our organization and the working condition that we create for others in our teams. And that is overwhelming. To make this process easier, we provide guidance, recommendations, and best practices in research and data science. Over the last 2.5 years, we've seen a massive growth in both our community and community resources. We currently host over 180 chapters across 5 guides, and several are under development. In order to ensure that our community members are able to participate irrespective of their previous experience, we provide guidance, templates, trainings, and pathways for them to stay involved. We have over 285 direct contributors on GitHub, where we develop all our resources, and thousands of users. Our illustrations alone have been downloaded over 6,000 times. For a community that started at a grassroots level, we are very grateful to have these members working with us. The project has impacted individuals, communities, research organizations, and resources, including policies at the national and international level. And I'm sharing a few stories with you from the project that demonstrate our commitment to fairness in our community process. Starting with findable. If the community resource is not in a language you don't speak, you will never find it. To make the Turing Way findable in communities that don't use English as their primary language, many of our contributors engage in the translation process. For example, Camila Rangel-Smith, along with other Spanish-speaking researchers in the community, are leading translation efforts. She says, although the international language of science is considered English, I know for a fact that not everyone in places like Latin America have the time and resources to learn it. So I think we must do everything we can to break those barriers and improve the accessibility of knowledge for everyone. This is her motivation to translate the book in Spanish. Camila is a research software engineer at the Alan Turing Institute and a team member in La Conga Physics with researchers in Venezuela and France. Moving to accessibility, Paul Ovoichow is a graduate student from Nigeria, and he was working with me as a Google Season of Doc participant on enhancing the accessibility in the book. And he says, not only have I gained a deeper understanding and appreciation for open source, but I'm also learning to prioritize accessibility, sustainability, and empowerment in the work that I do. My mentors helped me realize that the value I left behind was not in the amount of work I did, but how I enabled others' work. Paul is now pursuing PhD in the University of Glasgow. Emma Caron, a core contributor in the project, has further enhanced accessibility through development of guidance and glossary for GitHub users, screen readers, and book users of the Turing Way. Emma advocates for accessibility of publication and research through scientific communication and data sharing. She has documented and mentored multiple chapters across the Turing Way guides for collaboration and communication. Emma is a phytolith researcher in historic England, a community manager at the Alan Turing Institute, a mentor in open life science, and an incredible collaborator who builds bridges between multiple communities she participates in. Next, about interconnecting. By combining efforts to enable peer review and maintenance by global community, we can build sustainable and widely useful resources. Open research champions like Esther Plom from Delft University of Technology and Carlos Martinez from eScience Center Netherlands understand this value and contribute to open science resources. As data and software experts, they use and contribute to documenting best practices for data stewards and research software engineers in the Turing Way. Their participation enable the work of researcher in their organization, as well as benefit the wider open science community. Finally, about reusability. We engage with researchers from international communities from across different research fields who collaborate to develop chapters in the guide for project design, communication, collaboration, ethics, and community. We understand that to make our work truly beneficial and reusable for a broad research community, we need to bring contributors from diverse backgrounds in. And we build careful pathways for collaboration and dialogue to ensure that they are building something that they would like to use. These stories are just a handful of examples. As a project that is always a work in progress, we want people to come in and build a shared sense of ownership. And they can do many things with it that no individual can do alone. And I invite you to join us as well. I have linked a lot of opportunities in this link, but there are two main announcements they want to make, that I'm hiring a community manager and we are hosting an event called Book Dash. Please check out the details. Of course, none of these work would be possible without our community of collaborators, and we'd like to thank them for their thoughtful work and invite you to join them by bringing your perspectives in the project. Next, I would like to introduce you to Open Life Science. Around the same time as I had received the Software Sustainability Institute Fellowship, I was interacting with open researchers in my network. I had a chance to explore if we could serve more than one community at a time through intentional connection. Two of the brilliant researchers that I have the pleasure to work with are Berenice Batu and Yo Yehudi. In 2019, we collaborated to create Open Life Science mentoring and training program through Mozilla Open Leadership. At this point, the three of us had been wearing several community management hats, and we set out to build a platform that empowers individuals wherever they are to become open science ambassadors in their community. And we knew that we didn't want to do this alone. We wanted to bring people who were open science practitioners and leaders we had been inspired by and considered advocates from their local communities. With their involvement, our goal was to broaden access to open science skills and approaches through capacity building in 3 areas, which is we wanted to provide accountable space where people can come and learn and apply open science. We wanted to support diverse leaders by rewarding their grassroots efforts. And we wanted to build a community-oriented research by ensuring that the curriculum that we had designed is serving their community. During the program, our participants get one-on-one mentorship, expert consultation, training, as well as skill-up session on technical and social topics. The program started with 20 mentors, mentored by 20 people in the project, as well as we had over 18 speakers, 37 experts, and we were 3 organizers. All these was done with 100% volunteer capacity. And we knew that though working with fantastic people is great and rewarding, it is not enough to justify why people should work for free in open science. Most people who we could engage just could not afford to work for free. And the communities that we were incubating did not even have funds to pay for themselves. And therefore, we wanted to build enough capacity for us to create funding opportunities for our mentors and our participants. I will save you the details and directly jump to let you know that last week we kicked off the 4th cohort. We have received funding from Software Sustainability Institute, DENBI, Code for Science and Society, the Turing online training grants, and so on. And just because there are these small funders who are helping us build our sustainability pathway, we've been able to continue to do what we wanted to. In the 3rd cohort, we also onboarded Amy Sang, who has been a fantastic addition to the team. As Amy illustrates in this image, we have had consistent interest and participation from the community. By the end of this year, we will have mentored 112 projects with about 300 international participants from 6 continents. Several of our graduates return as mentors, as well as they bring new projects into the program. So our success is really defined by our participant success, and our participants have gone on to receive fundings, speaking opportunities, recognition, as well as a lot of funding from different organizations. So I want to share a few stories with you before I finish talking about open science. So the first one is Bioinformatics Hub of Kemia. They bridge the gap between well-established bioinformaticians and aspiring ones through peer training. They were a group of master's students who joined the first cohort and ended the program with launching the program as well as becoming a registered nonprofit organization in Kenya. At this point, they have been operating as a successful community. A few members who were also involved in Kenyan open science effort joined to support their work. They collaborate with African Research Network and recently have also received Code for Science and Society Fund. The second example is Gyanamuna, the Open Frugal Innovators of Media Lab Nepal. Initiatives were trying to help to solve problems of rural schools that lack science teachers and practical science teaching. Through her participation, Prakriti was working with Nepali Researcher Network and connecting rural students to quality education through open source Frugal DIY tool. And after finishing the program, she launched another project called Open Fowl to engage farmers in understanding science. The third project is Open Science Saudi Arabia. Batul is internationally recognized community leader in Saudi Arabia, who has been developing multiple transnational projects, as well as establishing a research software network in collaboration with researchers in India. After graduating from Open Life Science, she continued to build interoperable workflow to connect Open Life Science resources with her training efforts in Arabic-speaking communities and advocate for accessibility across multiple international communities as well. The value we create in OLS is impossible without the hard work of our mentors and experts. They participate in the program beyond their work, and they also help us build opportunities for our mentees. We are also very excited by connection they build with each other and integrate contextual knowledge in the curriculum of the program. One mentor, Anilda van der Wal, who was Batul's mentor, is herself an incredibly inspiring community leader from Africa. After the last cohort, she continued to guide Batul, and they have created a workflow and process evaluating best practices for sharing educational videos under open license. You can listen to their talk tomorrow at the Global Summit. Another mentor is Laura Asion. She has mentored Reina Gamacho Toro, who was leading a Lacunga physics project in Venezuela and Europe. And they connected with participants in OLS to explore challenges. Specifically, if the principle have been developed in Western country, what are the challenges associated to them when applying to Global South? This conversation really helped the team to design our curriculum with a basis to evaluate it, to make sure that what we are teaching is actually useful and incentivizing these kind of collaboration and communication. So just want to mention that Laura is also a co-founder of Metadocencia, who are doing a lot of these kind of connection in their own community. And since last year, they have taught over 1,200 teachers across 30 countries. Again, thanks to all the wonderful community leaders who make this happen. And I want to put this into perspective. All these communities are connected to each other in some ways or other. I'm not saying that everyone needs to be connected to everyone, but as neighbors, we can identify what kind of resources we can bring for other communities and what kind of collaboration we can build. And we can also think about how we can invest in these network and connections we build. I hope as I discussed fair communities, I was also able to highlight the valuable role of people in open science infrastructure, individuals who play key roles in the development, maintenance, and reuse of community resources. As Nadia Iqbal explores in her books, open science projects are built from the bottom up. It is akin to a group of citizens getting together and deciding they want to build roads, bridges, and highways that brought together previously isolated communities. As we all know, most open science projects run on volunteer capacity. Volunteers are researchers, professionals, and users who through their collective contribution build a better understanding of challenges and sustainable solutions. Through demanding process, some projects even manage to find funding to pay for developer or community manager. Unfortunately, there is still a prevalent view that since volunteer work help their reputation, this is justifiable not to pay them. The reality is that none of the open science project is useful or relevant without the active inclusion of open science volunteers. In addition to contributing to the technical aspect of the research, they do a large proportion of care work by facilitating community fairness through inclusive approaches. They are crucial for identifying opportunities, building visibility, mobilizing their community through collaboration. And they also help us build this interconnected web of open science infrastructure. With this scope, community leaders, funders, and industry stakeholders must recognize how investment towards supporting contributors and connection through one project can actually benefit a larger open science ecosystem. The change each community brings in the global science comes deeply from people's experience and personal frame of reference. Let's recognize people in open science infrastructure for their irreplaceable service and celebrate the diversity that emerges from global collaboration. And with that, I would like to thank everybody who's been part of all these wonderful projects that I had the pleasure to work, and I'm happy to take more questions.
Thank you, Dr. Sharan. This was unbelievable. I am so appreciative of you speaking so passionately about open science and among all reproducibility, saying it, positioning your talk from the very beginning that reproducibility is what is also important, and the reward, unfortunately, the reward system doesn't work that way. I am so grateful to be able to participate and to listen to your talk and to moderate your talk. Everyone, I think, here is clapping. A great talk. So do you want to tell me more? I see that your background is bioinformatics and all of that, and I think your cultural background, being born in India and in a society where people are used to care for one another and are socially conscious about the environment. Can you speak about personally how that your background and educational and personal has made you such a great advocate for open science and reproducibility?
Thank you so much for your kind word. And I am aware that I talked much longer, and I'm happy to discuss more things wherever we have the opportunity to. I think my background has definitely affected how I see and experience things. And I think growing up in small town, and when I say small town, we are 1 million people there. So it's very relative. But people were very connected. Right now, I'm in Ireland and in my partner's city, and people in 50 kilometers, everybody knows each other. Everybody is helping each other during pandemic. Even if the shops are closed, people know who to go to for whatever. And I think that feeling of knowing that if you don't have something, you can lean on others is a really powerful thing. In science, this individualism that I was exposed to for a long time just doesn't help, because asking for help makes you feel vulnerable. Asking for help makes you feel an imposter in science, whereas the idea of help is to generate collaboration. So I think, everything we experience really comes from where we are, the life that we have lived or research that we do. So definitely my personal background has affected. I think bioinformatics has very little to do with my experience, but people in bioinformatics that I'm working with have inspired me tremendously. And they have really, I think I should mention Konrad Forstner, who was my supervisor back then, was so passionate about open science that I had no choice but to like it. So I think people, have inspired me in different ways, and I'm really thankful to them.
And I heard you mention my dear friend and former Force 11 board member, Dr. Leslie Chan, who has been such a shining star on the horizon of everything open access, open science, that I am so grateful that you have also found his work inspirational.
Oh, beyond inspirational. I think a lot of time when we move from global south to global north, we kind of start learning the behaviors in global north and try to, forget what we brought with us. But his work really kept me grounded. His work made me appreciate and respect the culture and tradition and, experiences that I brought from the global south. So I really am thankful for, the work that he does, the challenges that he brings in open science in a way that, he's been advocating for over 20 years, and we are still there. What's the problem? Why aren't we moving? So no, I am highly grateful for Leslie for his work.
Yes, absolutely. Let's see if we have additional questions. Q&A. We have what languages is the Turing Way guide translated to? There is a question from Gabriela Fisova.
So the Turing Way currently is being translated into Spanish. We also have a Chinese translation and French translation happening. But we do it through a platform called Transifex, where anybody can request what language they want to translate it into. And I also want to make you aware that you cannot do it alone. Translation is really hard. So if you're interested, just mobilize the community that you're part of who can help you in doing that. And it also creates accountability if you're working with multiple people.
Good. I see another one. Our tomorrow speaker, Laura Rovelli from Argentina. She's congratulating you on the excellent talk and presentation. But she does want to ask if you can tell us more about the work that you are doing promoting findability, breaking down language barriers toward multilingualism, and if this also involves biodiversity and any example of those actions.
Yeah, so Laura, I'm going to connect the question with the previous one. So as we in the Turing Way are already very open to the idea that, the knowledge should be available in the languages that people learn it from. But also in open life science, we have mentors and experts from different language and different communities who are mapped based on what we are required. In terms of bibliodiversity, we are also, for example, we had one member from Indonesia, and they were talking about how a lot of their tradition is about oral history, and people talk to each other more than they write stuff. And how can we actually promote different kind of knowledge production, and how they can coexist in the space that we are, doing science through publication. So I don't think that I am very much aware of how we can improve bibliodiversity, but I'm aware of the problem. And therefore, in the training and teaching that we do in open life science, we try to ask people to think in their local context rather than adopting the Western ideas or Western standards that we are used to.
I was going to hand over the torch to the moderator of the panel, Dr. Ioannidis, but he has a question for you, Dr. Sharan. Have you had any instance where some competition among its members would benefit a community and therefore openness should be limited?
So I'm going to read that question because I think I didn't understand.
It's in the chat. Can you see that?
Oh, yeah. Okay, I do not think that competition in any way is beneficial. I think you can have healthy competition, and I'm going to give an example. I was watching a hurling game yesterday. One of our niece was playing, and the two teams that were playing, they were friends with each other. Their rivalry is just on the ground because they want to, find the best way to play hurling. Once they are out of that ground, they're friends again. So I think we need to learn from that you can have competition to build the best tool possible, but not at the cost of suppressing some other's work or not acknowledging what has been done before. So I really think that competition is good in a context, but not in the global context of open science.
Thank you. Thank you so much. With this, we are concluding. We are 2 minutes over. And now it's time for Dr. Ioannidis to welcome the panel session we have today. So thank you.
Thank you so much, Violeta.
Thank you very much for the introduction, Violeta, and for the excellent talk of Malvika. And it's great to see the spirit behind all the work that you presented. And by the way, my question was indeed about healthy competition that could be beneficial, not fighting, but on particular context and ground. So I think we are all on the same page. So I would like to ask let's see, I will present a panel and let me share my screen. This is the first, this is the panel, but I'll let me see the sharing part, share my screen. Okay. Do you see my screen?
Yes, all good.
Okay, great. So the panel is titled Opening Artificial Intelligence, the Next Open Science Frontier. And the main thing is the following. Actually, our keynote, Malvika had a very beautiful picture. I wish I had it, that showed openness and open science in the middle, and then various aspects of open science around it connected. And I have a few mentioned in this slide. We had for a very long time open source software, research infrastructures, telescopes and ships and microscopes and so on, open access to those. And then from the Berlin Declaration, let's put that as a starting point, open access to research publications, later to data, and so on and so forth. We are opening up a whole bunch of things. What is the next frontier? What is the next big challenge of opening it up? And the object of this panel is opening artificial intelligence. Artificial intelligence, yes, it's related to software. Yes, it's related to research infrastructures, more or less to everything else. How do you open it up? And the panel objective is dual, to explore two things. First of all, the boundaries of opening artificial intelligence applications, all kinds of boundaries. And also, is this related to open science? Open AI and open science, are they just one, a part of the other, or not? And the background of the discussion that we have faced in the past are that we could explain through our discussion, but also as a background, is there are some key challenges, technological, ethical, and so on, in using AI in educating, in doing research, which is open science is very key on, in health, in government, in transport, in a whole bunch of other sciences and activities of our society. What are the key aspects of an ethical AI? What would ethical AI mean? And there are various, of course, approaches to this, but what are the key aspects that we should worry about? And how can key concepts of openness in the things that we already understand quite a bit in software, data, service, and so on, are related to open AI? And how we can learn from this and create key technical, legal, ethical, and so on constructs that will allow AI openness. So with this background, I've raised a few questions related to the panel of opening up AI. Briefly, I won't read the text of the questions, but the first one is how we can reconcile between opening artificial intelligence and how can we offer open AI and data analytics service on top of private data. Openness and privacy are two conflicting concepts, or are they? And how can we do that? Opening up AI, what does it mean to the goals of the society that we want to achieve, where that equality, equity, justice, very similar but related areas. How can we achieve those in AI? By opening it up. An important concept in open science is as open as possible, as closed as necessary. What does it mean in open AI? Does this move? Can this be inherited in open AI? Is the competition where you need some closeness of the tactics of the two curling teams that are friends, but yet when they compete, they need to have some closeness. So what do we do when it comes to science and open AI in that context? How can we optimize the trade-off between openness and utility? Sometimes openness reduces utility and vice versa. What is the right trade-off? Again, from technological, ethical, and other standpoints. And finally, what is the legal and regulatory framework on AI currently, and how does this affect the technology towards open AI? So these were the 5 questions. They were not mandatory for anyone to answer any of them, although I think some of them will answer some of them. And in addition to the questions, there are some cross-cutting dualities that may have very different answers. I mean, these questions may have very different answers in the two poles of each duality. So does industry and academia answer some of these questions the same way? How about Europe versus the US versus the rest of the world, Asia, Latin America, Africa, and so on? I just put EU and the US primarily because of the panelists, but obviously the regions of the world have a play there. And then one scientific field, industrial sector, social activity, societal activity, and so on, versus another. Is the same thing for medicine as it is for finance and so on. So we have assembled an amazing panel that I have an honor of coordinating it. This was the panel until a few hours ago, but John Donovan informed me the last minute that due to some family emergency, she cannot participate. So she is replaced by Prodromos Chebos. And I'll very briefly introduce them in the way I see them from left and right. Prodromos is a lawyer, and he's head of digital development and innovation at Onassis Foundation, and a legal advisor to OpenAIRE, the main flagship infrastructure for open science in Europe. Michalis Kritikos also has a legal background, and he's a policy analyst at the European Parliament, and he is an ethics advisor on science technology in the various committees of the European Parliament. Natasha Milic-Freiling is an entrepreneur and CEO of Intact Digital that makes legacy software and services operational even today, but has an industrial background working in Microsoft and also academic in the University of Nottingham. And last but not least, Alex Wade, who is now Director of Strategic Partnerships at Allen Institute for AI, but has been before in the Chan Zuckerberg Foundation, Microsoft, and also in libraries at various major universities in the US. These are the panelists. Each one will have 10 minutes to present, and you should be holding off your questions until all four give their presentations. And then we'll have about 25 minutes of discussions where you can ask the entire panel, individual panelists, and so on, all the questions that you want in the Q&A. And if you have trouble, the way I had, then in the chat. And because of the way the things that they will focus on, it's almost in complete reverse alphabetical order, or reverse presentation order, I should say. Alex will go first, then Natasha, then Prodromos, and then Michalis. So without any further ado, I'll stop sharing, and the floor is yours, Alex, with the 10 minutes ticking. I will give a signal about a minute before the end, so that you know that, okay. So Alex, the floor is yours.
Wonderful, thank you very much. Let me share my presentation. And 1 second. You surprised me with calling on me first, and I was not prepared. So give me 1 second here.
No problem. Good things are worth waiting for.
My clock is already ticking, so let's see.
No, I froze it.
Well, I'm struggling once again, so I'm going to jump into my slides here. You're watching me navigate, I'm sure.
Something has showed up, but just a thin column of color, not slides. If you don't mind, then you may need to work some things out. Shall we jump to Natasha, and then you can let me know when you're ready. Natasha Milic-Freiling, could you jump in? Thank you.
Hello there. Yes, my pleasure. Thank you for inviting me. Let me just try now to share my screen. There you go. Can you see a window? Should she see the PowerPoint slides? Is that correct?
Yes, we see them.
Okay, let me just.
As soon as you make them full screen, it will be ready to roll.
Great. Yeah. So so when Yanis asked me about the presentation, I said really for the panels, I prefer to do discussions, and I picked here 3 topics. And I say these topics are sort of have been on my mind for a while. First, as an academic, I was chair of data science in the University of Nottingham for 5 years, which then involved working with computer science students and, of course, researchers in AI primarily. It was data science, machine learning, AI. And one thing that I observed was that everybody was grabbing the AI title. So even the traditional statistical methods suddenly became AI. So I first want to make a comment. As we are asking about ourselves about opening AI, it will be also very useful to talk about what we mean by AI that is of interest and what we want to be open about. So that's going to be the first topic. Then I will discuss briefly of what I believe is likely to have an impact, because when you're asking people to do anything, you have to be very clever. You can't ask them to do many things. So you ask people to follow and contribute things so that you believe will have the highest impact. So I'll comment on that a little bit. And then I have one suggestion that we need to all do to improve use and sharing of AI in general. And I won't tell you what it is until we get to that, okay? So first about opening AI topics and what to be open about. Because AI now means many things to many people, the answer is very important, and that answer of what we want needs to be very much informed by context and by, say, technology that we believe will be useful. So for those people who do not code and do not use AI in anger, like master students or undergraduate students or PhD students, they're the ones who, in fact, create algorithms, working with professors and others, innovating constantly, creating new models and so on. So it is very, very useful, in fact, to see what they do and what you can ask them to do if you want them to participate in any type of openness and sharing. And it was already mentioned about a little bit about competition and so on, but I would really want to focus on the practices that we put in place that are serving certain purpose, like in academia, ensuring that innovation goes forward, ensuring that the new generations are informed and educated. We put them in the boxes and say, you better have X many papers in AI so that you can get your PhD in AI. And those, those papers need to have you as a first author. So we need to think about what is it and what is the context in which AI innovation happens, and then in which context is getting applied, and then in which context we want it to be continue to be applied. So that's why I'm basically saying we need to dive deeper into what AI means before we can say what we want to share. And here I just mentioned a couple of things. In many instances, people apply algorithms, and you see those algorithms already exist. You can get them off the shelf, if we call them. You have them in different suites of tools. So I personally will not argue and say I must have that AI algorithm, because they are there. It's there because it is becoming a commodity. You can use them. Now the second bit is the code that is AI code, if you wish, the programs. They then require data because most of these systems are learning from data. Now that becomes a tricky bit because the data comes from another stakeholder. So we have now code, we have data. When we put all this together, we apply training and so on, we come up with a model. And so there is an output of this symbiotic relationship, symbiotic sort of procedures between the coded algorithm, the data, and the process in which we created the model. You can argue you want to have a model shared. And then if that's the case, then we would need to understand better whether that model reveals anything, say, from the data that the data stakeholder may be worried about. Yeah. So the main point here I want to say, if you're going forward with the AI, opening AI topics, let's engage then with people, practitioners who are doing it, and let's see precisely which context requires what to be shared. Because if you come up with some kind of policies, blanket policies that would supposedly enable opening AI universally, it's very likely that that will be shut down. It doesn't matter how good intent may be behind that effort. If the stakeholders feel that there is some risk and that risk is not addressed, it's not going to happen. And in fact, it may backfire very badly. And I'm speaking from as somebody who lives in UK, and recently, NHS decided that they would like to support innovation by sharing data some data from patients, and that backfired because it wasn't managed properly. The press says one, the expert says another thing, and people are confused. And guess what? People may just starting to opt out. So even the best intent can go wrong unless there is this clarity and the stakeholders' interests are addressed. So I'm going to go to the next one now. It's about what's likely to have an impact. And again, we know that there have been so many benefits from sharing data. So open data has really gone far because people can use data in new contexts. They can use them in combination. They can derive new insights. So we have kind of already practiced how to have that impact through the data. Now the question is, if you start doing a similar thing with code and with whatever we believe AI should be shared, we probably cannot make too many asks, as I said, because in many instances there is a complexity of multiple stakeholders, and you will have to manage that very carefully. So I would just say that if I have to choose between somebody giving me a code and somebody giving me instructions or experiences or insights that they have gained from their applications of a particular technique, I would choose the latter, because in many applications you have to modify models, you have to modify code, you have to do this because it's the nature of the area. But the insights that was gained to previous applications and previous research, that's extremely valuable so that we don't make the same mistakes. And that comes, believe me, that comes from the experience I have simply getting new students and they're having to learn what has been done before. And the importance of transferring this knowledge, even the smallest skill that may take you 2 hours to figure out how a certain feature works, well, somebody can tell you in 2 minutes. So there is a huge productivity loss, and there is a huge waste of resources, especially if you're talking about projects that are funded from research councils in a best intent to promote innovation, yet the waste of time and the wastage from not transferring that knowledge is huge. So if I want to say the impact is not going to be necessarily sharing code, the impact will be in the sharing of practices. And the last thing I'd just like to address, if you ask me now from the perspective I have working in industry and also now working with my company, what we need to do is make sure that AI and other algorithms are reproducible. Essentially, without reproducibility, we cannot do validation. Without validation, we cannot guarantee anything. And that raises huge issues with the ethics of applying it, the accountability, the responsibility, and eventually, if somebody applies it in the wrong way, it's the liability. Yeah, I'll stop here. Thank you.
Thank you very much, Natasha, for your timeliness and also for all the issues that you raised. And so openness is the key message that I keep. Is openness is for sharing experiences, sharing intangible things and not the code or the data and so on. And let's make everything reproducible. Excellent. I see Alex being ready. Thank you very much, Alex. So back to you.
Great, thank you very much. I'm going to do this without going into full screen mode. And I want to couch my sort of introductory slides here a little bit in my experiences and my potential biases that come in. So as Janis mentioned at the beginning, I have spent a considerable amount of my career working in industry for some very large software companies. But in that context, I think of myself as working more in research organizations. So half my career at Microsoft was spent with Microsoft Research, working on Tony Hayes' team as we produce things like the fourth paradigm, and now with AI too, certainly a research organization. Also through these experiences, I have spent a significant amount of my time working in open advocacy. So at Microsoft Research, we instituted an open access mandate. At the Chan Zuckerberg Initiative, I worked on our open science funding group. And I've been participating in many of the dialogues around the principles of open scholarly infrastructure. And then yet a sort of a fourth hat or a fourth sort of camp I find myself in is really in the product development area. So working on applications like Microsoft Academic, Meta with the Chan Zuckerberg Initiative, and now Semantic Scholar. So these things are part of the dichotomy that I will be struggling with today, is sort of talking about this from an industry perspective, talking about it from the research community perspective, and then talking a little bit more philosophically around where my feelings are from an open perspective. I am now with the Allen Institute for Artificial Intelligence, and I'm working on a product there called Semantic Scholar. And I'm going to frame the rest of my talk around some of the things that we're doing and try and surface some of the, the desires that we have for being as open as possible, and then some of the challenges that come along with that, and try and address some of the points that Yannis presented at the beginning. So what we are doing with Semantic Scholars, for people who are not familiar, is processing millions of papers, building up search and discovery tools, and trying to develop and apply some state-of-the-art natural language processing, machine learning techniques to help scholars struggle through or navigate through the literature. And this surfaces in our product right now in a number of different ways. This isn't a product tour, so I'm not going to describe this for you, but there are things like recommendations, libraries, different things that we can surface out of the full text of the research content, and presented in various ways to the user. But there's also byproducts of us developing this core application. We expose all of the data that drives this application via an API that you can access. We also provide it for the natural language processing community, full archive downloads of the corpus, or full with an asterisk by it. There are certainly things that we can't redistribute, depending on the agreements that we have with the publishers or the various licenses on them. But the Stork corpus that we expose today has about 136 million paper metadata records in it, and roughly about 12 million full text publications that span all domains. And this is something that has proven to be very useful in the NLP community. And then as well, we strive to release, to the extent we can, most of our machine learning models that we're developing. So an example of that is STAND, which is our author name disambiguation model, as well as some of the training and validation data that we use for that. So those are some examples of the API, of the data sets, and of the models that we're striving to expose in this space. Now, we have a couple of assets that help us do this. We have a research organization. It's not a large organization. We have about 12 researchers devoted to the Semantic Scholar project area, who are examining a number of different research areas. But we also have access to a large amount of content thanks to the publishers who have been sharing the full text and in many cases closed access content to us in order to build these discovery systems and recommendation engines. So just to tie this back to something that Malvika commented on in her notion of sort of communities here, each one of our researchers operates within their own computer science community. We have researchers who are working in natural language processing, in information retrieval, in human-computer interaction. And each one of these communities has its own evolving sets of norms and standards about what artifacts get exposed when you are producing a paper, for example, on some of the products that we've done here. So I've given two examples here of research projects that we have written up open access papers about, and wherever we can, we are either making reference or including the data sets that were involved in training and evaluating these algorithms. Touching on something that Natasha was just talking about, oftentimes it's less about open sourcing the algorithm that you're using to develop the model than it is about exposing the data that was used to train that model. And so, one example of that is in the case of SciBERT, where we have created a scientific language trained version of the BERT language model. We created a corpus of about a little over 1 million full text papers, largely in computer science and the biomedical domain, but not all of these papers are open access papers. So there's some decision trees around, should we have built this solely on open access papers, or are there some stepwise stops along the way where we can say, we can't share the entire training corpus because we don't have the rights to, but perhaps we could provide some level of auditability and fuller descriptions of the decisions that went into that corpus selection, the data cleansing that went into it, et cetera, leading closer to reproducibility in that front. And then lastly, I want to touch a little bit on the prompt around AI for equity and inclusion. And this also loops back to a couple of things that Malvika mentioned in her keynote earlier today, is that for the most part, the scientific literature, the domain in which we are working, is inaccessible to large chunks of the population, either because of language barriers or because of device and connectivity barriers, or the packaging in which a lot of the literature is produced. And so as we get access to the full text, even of this closed content, we are starting to experiment with new ways of training models to convert the inaccessible PDF packages into more accessible tools like SciAlly, which converts the PDFs into reflowable HTML, or the semantic reader, which helps users navigate equations and citations, et cetera, within the document. So I think there's a lot of possibility for AI to be applied to the problems of equity and inclusion. So it's not just the openness of the models in doing this, but it's ultimately the openness of the content that can make this possible. And I will stop there.
Excellent. A very promising glance that you showed us, Alex. A lot of wonderful things that are happening and interacting with other efforts and going deep at various levels. This is exciting. Thank you very much for this and for even being less than winning back some of the time. So how should I put this? I mean, both Natasha and Alex presented goals, wonderful things that we can be doing and reproducing and changing and so on. And the scientists and technologies and so on are pushing in these directions. And then come the lawyers and they enter the party. And then maybe the picture they draw is somewhat different. Let's see. Brotherman, it's your turn.
Hello everyone. I don't know why I get all these kinds of introduction always. I'm not the most let's say pleasant possibly company in these kinds of conferences, but I do sympathize with the scientists that lawyers actually tend to be less than welcome in quite a few of these instances. And
you are the kind of lawyer that you are most welcome. That's why you are the panel. So yes, but yeah, the laws are the issues. So please enlighten us.
Can you actually see my screen now?
Yes, but not in full screen.
Not the correct one. Let me just get you the correct one.
Maybe it was the correct one, but it wasn't full screen.
Right. Now it should be.
It is indeed.
All right. So what I as Yanis very accurately predicted, what I want to actually introduce is the kind of problems that my fellow lawyers face when they have to deal with the issue of artificial intelligence, especially as it is incorporated in platforms, and what happens with regulation. And I think one of the key starting points is how the problem of regulating platforms has been displayed even in literature, and how we view that as a problem. And I think one of the starting points I have when I talk about these issues is an essay, which is actually quite old one. It doesn't come from a lawyer. It comes from an artist by Hito Style, when she wrote back more than 10 years ago that internet is dead. And she wrote that to describe the situation where we cannot really distinguish between physical reality and digital reality because we are constantly connected. What happens is that we get constantly connected and we develop a new form of reality, which is very different even from the nightmares of the early 20th century in terms of mechanization of life. And they are closer to what Zsuzsanna Zuboff has described as the surveillance capitalism. And I think this has been a very popular book, and the papers have been very popular, when she describes this situation as a situation where we are constantly mediated and we are constantly, our data being constantly extracted in order both to produce value, but also that being an essential design characteristic of most of the platforms out there. Whether you talk about a platform that supports scientific work to be published in the form of ResearchGate or academia, or in the form of Facebook or Instagram. And the reason why I put them together, I know they are very different technically speaking and design-wise, but they actually obey the same economic logic, which is that of constant extraction and mediation through algorithms. And that's quite important because one of the things we want to describe and one of the things we want to tackle in terms of regulation is how we counter this paradigm. And this is something which is a paradigm which is very much interrelated to how value is produced. So we talk a lot about how we can regulate artificial intelligence, and I totally agree with Natasha. This is something that is used as an umbrella term. It's not necessarily AI, but pretty much everything related to any kind of algorithmic service, and I will take that as my working definition here, eventually is being used in a commercial setting in order to produce value through the extraction of data from different types of data subjects. So we cannot really talk about how we're going to algorithmically regulate and support openness in algorithms if we don't understand how the value is produced. And this is a very important point, and that's the first point which I want to make. And I think I'm having the picture of Ruha Benjamin here because in her book, Race After Technology, she talks about how we have this strange situation where we at the same time have to deal with two problems. One is that we are going to be, whether we are scientists or citizens, we are constantly monitored and extracted. And at the same time, we tend to impose our own biases on the technologies we produce. So we have multiple fronts we have to fight with, and regulators do understand that. And you can see they have different approaches. A classic approach is to view the whole problem of algorithmic regulation as a competition law problem. So how do I manage to regulate access to data in different ways? And this is not normally the context where we approach this problem in the science discussions we have, open science. But it is something which we've seen also being the one which it's the primary driver for even European legislation, whether we talk about the Digital Markets Act or the Digital Services Act. And I hope Michalis can also tell us a few things about that as well. But what I would add is that we have also other forces that actually could impede the way we open an algorithm when we do research. And this has to do with how we share research in the current global setting. So when we have this whole discussion about decoupling at a global level, it seems something very different, very far away, which means basically how we can have self-sufficient supply chains of goods, technology, and data in different major jurisdictions like Asia, United States, Europe. But it is something which increasingly becomes an issue of strategic management. So how do you manage to increase your self-reliance? And in that sense, will you open when you know you're going to end up there? And again, this fits back to the researcher for a very simple reason. We're increasingly asked to develop technologies, not just for research purposes, but also to be able to do some kind of technology transfer that is going to lead to a market. In addition, to add to the problem is that normally we think of technology as something that is the actual object of regulation, and in that sense, it's pretty much the way regulators still approach the whole problem. But as you can see here, when Amazon tries to stop the FTC chair, which is Lina Khan, from her position, who's a vocal advocate of how big tech should be regulated, they increasingly play a more important role. Of course, we can see that more clearly in China, where we had very clear interventions. But I think what is most interesting is that also the way we regulate, so the way we can regulate openness, it can be seen as a commodity, as something not in the sense of commodity that's something you can find, but something that you actually can sell. And I think the latest version of the Apple operating system is to such direction, not in the sense that it's going to solve privacy problems, but it shows us that a specific function of regulation, here it's not openness, it's more about privacy, it is something that can actually even be packaged as a problem. Of course, it doesn't mean it's not going to have a reaction as we've seen in the snap. But I think the most important document here, and this is something that Natasha has referred to and Alex before, is actually how can we think of the regulatory process methodologically as something that happens at the design level. And I think this is the key question here. So how can we not think of regulation as something that comes ex post, but something that actually happens at the moment when you're designing? And the reason why I mentioned all these things before is to actually show you that there's no other way. It's too late afterwards, or it's not even that you're a monopoly in doing it. So it's the moment of design, which is a regulatory moment, and that's the moment we should be focusing our efforts to. Of course, design and regulation sometimes they're a chicken egg thing, because we correspond to what we've designed, and we design what it allows us sometimes to override in order to support regulations. And I'll finish the presentation with, after having shown the difficulties, and actually difficulties that have to do with the categories of regulation and design, with going a bit with some other fundamental problems we have when we try to open up algorithms. And I'll use an example from an exhibition that's wearing one of my two hats, the open air and the Onassis one, that comes from an exhibition in the summer. And this was a work made by an artist called Before the Bullet Hits the Body, and it's as you can see, it's not necessarily an algorithm. It's basically an equation showing how crime is measured in the LA area. Now, what this artist did is that he actually took this let's call it algorithm. I understand it's not, but he took this equation and put it in about 30 meters stickers on the ground, and that shows us something very simple with algorithms and so with technology artifacts in general. It's very difficult to explain. It's very difficult to open. It's very difficult to understand. So these are the problems which we know even from 1956, from the classic book of Schellenberg on modern archives, that we have a problem when we try to open up things which are not mere records. So it's sometimes easy to actually just say that this minister or this particular type of work has been, this particular type of decision has been made on the basis of these papers. But if you're trying to identify the logic behind the decision, that's not something which is always easy. And notoriously, the problem that we have is, as mentioned before, is we need to open the algorithm, we need to open the data set, and we need to make sure that we can actually do that in a way which is meaningful. And we know that this is a problem because we have a provision in the GDPR which actually allows us to do so. If you see Article 13.2 of the Data Protection General Regulation, you will see we have a right to actually open up the algorithm and object to automatic decision making if we believe that there is a problem with the decision. So very simply, if you have a decision that involves your life in a hospital, or it involves your credit score in a bank, you're allowed to have access to the algorithm, understand it, and then see whether this has been correct or not. But as again, we know that we have a classic problem, which is
1 minute.
it's very difficult to basically predict what the algorithm will do, because that's in quite a few cases the whole deal. The problem is that we create rules for controlling algorithms, but it's very difficult to explicate them, it's very difficult to explain them, and it's very difficult to make sure that they provide the ground for a meaningful legal response. So finishing, I would say that it's very difficult to deal with algorithmic transparency and openness, but at the same time, we know the basics of how we do it from our past experience. So we know that the designer, the ethicist, and the lawmaker should meet at an earlier point, not after the design of the artifact. We know that we need to see how we can even individually introduce principles like algorithmic self-reliance. We need to know that we need to understand the limits of opening up an algorithm, and we need to develop codes of ethics that they are not just a dead letter, but they can actually work. And finally, I think it's impossible to think of ethics today outside of design and engineering. Thank you very much.
Okay, thank you, Prodrome. You put even more questions to be raised after Natasha and Alex. No, but they get interleaved with everything that has been said. But let's leave this also to afterwards. Michalis Kritikos from the European Parliament with various hats, legal aspects, policy making. Michali, the floor is yours.
Thank you. First of all, thank you for the invitation to present. I don't know if you can see my screen.
Yes, although not in full screen. So if you could, yeah.
Okay, good.
Excellent. Now it's full.
Great. Thank you. Thank you for the invitation and for the opportunity to present what we have been doing here at the European Parliament for the last few years in the field of AI. And I'll try to also to connect our work with the challenges and the questions raised in the community of open access. It's also very difficult and challenging always to follow up a presentation of Prodromos. I'll try to keep it up, but he set a very high barrier, and I'll try to present things in a less rigid manner, although it's a much more institutional way of looking at things. First of all, I would like to kind of offer you a snapshot of what the EU as a whole has been doing in terms as a legislator in terms of trying to regulate, to control AI in different ways. That is a slide that shows, that indicates, provides a kind of highlights of the work of the Commission in that respect. Most of it is in the form of communication, so soft law. Recently, on the 21st of April, a few months ago, the Commission came forward with a proposal for a regulation on AI. And that is something that is, I'm going to present a bit later on. That is something that is nowadays discussed within the Parliament. And if we have time, I'll kind of inform you about the stage we are in terms of handling this file. At the same time, beyond the communications and the different soft law instruments, the Commission set up a high-level expert group on AI, whose purpose was to produce ethics guidelines. So these experts came together, and after a year and a half, came forward with 3 different features that should somehow an AI system should contain and should meet as a requirement. And this is the so-called trustworthy AI. That's the kind of EU jargon about AI, the way EU views this kind of disruptive technology. So AI systems should be lawful, ethical, and robust. And there are 7 key requirements, 7 key ethical principles, as they call them, that they have to be met in order for that system to kind of be developed and deployed in an ethically sound manner. You can see that some of them relate to our discussion: transparency, accountability, human agency and oversight, technical robustness, privacy, and ensuring diversity and societal well-being. That is a document. You can access it. I can send you also the links. Beyond that, I have to say that this expert group produced 3 other deliverables that are worth being read, that try to somehow translate these high-level ethical principles into concrete recommendations and points for action. Beyond that, the Commission produced a few months ago, as I said, an AI proposal, which follows a risk-based and human-centric approach. So the main idea behind the proposal is to offer a nuanced way of looking at risks posed by AI. So have unacceptable risks that cannot be taken within the EU at least, high-risk AI applications or uses that have to be regulated in a much stricter way than the rest, imposing all sorts of ex-ante legal obligations, limited risk applications, and minimal risks. The last 2 categories, somehow can be controlled and managed through conformity assessments. There are 4 indicative somehow actions and examples that the Commission has highlighted that are prohibited at the EU level, and these refer mostly to social scoring, subliminal techniques, exploit any vulnerabilities, and biometrical identification in public spaces, something which is already has become an issue of legal debate within the Parliament whether facial recognition should be banned in the frame of the upcoming regulation. And these are, as you can see, uses of AI that Prodromos mentioned before, where many scholars have referred to as being the dystopian way of viewing AI and the internet as a whole. The timeline for the regulation is the following. We basically need to spend at least 18 months or so in order to have this piece of legislation being read and reviewed by both legislators, the Council and the Parliament. And of course, the final version may surely look, I think, much different than the current proposal. At the same time, I have to also mention, not only because I'm working for one of the 2 legislators, but simply because EP has been the agenda center in that respect. The work of the EP in the field of artificial intelligence has been quite important since 2017. They adopted a resolution that became famous for the wrong reasons on the civil law rules on robotics, a resolution that proposed for certain forms of artificial intelligence and robotics to acquire legal personality. That resolution was followed by other own-initiative resolutions. The last one was adopted a few months ago on the ethics of AI. At the same time, the European Parliament set up a special committee on artificial intelligence, the so-called AIDA committee, whose purpose is to produce a report on the challenges that AI is causing and how Europe should, make use of these technologies and develop this technology in order to compete with US and China. And within also the Parliament, there is a Center for Artificial Intelligence that was established at the level of STOA. STOA is a panel of science and technology, a panel that brings together 27 members of the European Parliament that have a special interest in science and technology issues. Now, going back to the original discussion, to why we're here to discuss how AI and open source, open science, open access can be linked. From what I've read, there is no reference to the proposed regulation to the role of open software. There is no reference, there is no mention, there is no discussion, at least until now, to whether we should think of open science, of open source, as a way to address, to meet the aims of the regulation and to address some of the main challenges that have been somehow discussed and debated throughout the last 3 years with regard to artificial intelligence. So open source software is largely absent from the discussions. So I kind of tried to come up with some suggestions as to how our ecosystem, the Brussels ecosystem, can get hold of that discussion, the open AI discussion. And I think that a way to look at open source should be a positive one, as a way to make AI ethical, as a way to address problems of algorithmic bias, and also as a way to democratize AI, to decentralize AI, and offer the opportunity to many stakeholders, not only to review the code, as many have said, using the right of explicability or transparency, but also to be part of the design process, as Prodromos said. So ethics by design also being a much more inclusive exercise rather than being left in the hands of experts. I'll stop here and I'll leave some space and time for discussion. Thank you.
Thank you very much, Mihaly, for this tour of the regulations and where we stand and all the questions that are being raised. And thank you all the panelists. The initial presentations and positions have been brought up. I would ask all four panelists to please turn on your cameras so that the audience can see all four of us at the same time, all four of you at the same time. And we are waiting for your questions in the Q&A text on the side. Some question has been answered already. You can check it there, or you can pose your question preferably on the Q&A or the chat. As you may be preparing for this, if I may ask if any of you have any questions for one another, or to having heard what everyone else said, if you want any additional points. So go after each other, so to speak, in a community way, not a competitive way, in a communal way. So, and any questions among you? Alex, please. And then Mihaly.
So Mihaly, a question for you. On that risk pyramid that you showed a second ago, was there any addressing the audiences to whom it is a risk? Is it all sort of couched in the terms of the end user public, or in the case of anti-competitive behavior, does that risk model apply that way, where an AI model deployed by one company may threaten the existence of another?
Yeah, it's I would say stakeholder approach to risk. So they can try to predict what type of risks will kind of affect and harm certain communities. So there is no reference to issues of competition or to whether there is a risk of techno capture, that certain large multinationals will have captured the agenda and are kind of monopolizing or harvesting data sets at the expense of the society. It may be brought forward now by the parliament as an issue and as a separate challenge and separate risk that needs to be addressed as well. But as a societal, I don't see grand risks there. I see sectoral risks or use-based risks. But that's the main discussion right now in Brussels. What kind of methodological tool are we going to introduce into the regulation so as for these risks to be assessed in a uniform and consistent way? And that is a big discussion right now. How do you define a risk in the field of AI, and how do you assess it, using which tools?
Thank you.
Great. Alex, you had a follow-up, or? Okay. Yep. We do have a question in Q&A, but Mihaly, you had something that you wanted to ask right before. Yeah. So I have a
kind of conceptual disagreement. It's not the first time with Prodromos about the ethics by design approach.
Okay,
which is a big discussion also here in Brussels. Everybody talks about ethics by design as a silver bullet that will try to solve all sorts of challenges. And this is an approach that I think has been copied, has been transferred from the GDPR. The privacy by design approach has now been seen in the clothes of ethics by design. It's a sound way of looking at ethics, but Prodromos also said ethics shouldn't be seen only as a design problem. But I think in the field of AI, it can be as a constraining factor. So you cannot predict everything at the design level, and you cannot have everything at the outset. It's such a dynamic and transformative technology in certain sectors where you cannot predict everything at the beginning. So for me, it's much more important. Of course, the ethics framing is important as a concept, but I think it's much more important to come up with the concept of ethical audits, of monitoring the ongoing deployment of technology as it goes, and then to have the legal somehow power to freeze or to introduce certain safeguards in order to make sure that the technology doesn't develop unwanted uses or doesn't, get out of the control, the so-called black box problem, out of the control of the regulator or of the user.
Right. Rodrome, what do you have to say? What say you?
What say AI? First of all, I'm really glad that Michalis raises this point, because I understand and I agree it's a holy grail, the whole ethics by design, and it is indeed transferred by the privacy by design, not even from GDPR. It comes from the Canadians, so it has an even longer story behind it. And we've seen that also when we had the discussion about openness. So open by design has been also something coined in the policy, and it's sometimes useful for the policymakers to put under the carpet of design the things that they are black box to them. However, having said that, we know those that have done development, they know that there is no waterfall model. So it's not that everything happens at the beginning. The design is a constant, it's a constant moment. So you start with something, and as you move from one version to the other, you have constant iterations when you always have to make these kinds of considerations. You always have to take these kinds of considerations. And the whole point of my presentation was it was a methodological point. The problem that we're facing, and you mentioned that in relation to Alex's question about risk, is a methodological one in terms of how do we intervene, when do we intervene? And the point, again, is that we are not alone in the room. So if we think that, and we know that for good and for real, we know that when you have super regulators like FTC in the US or the Commission here, and they cannot handle big tech because it's too late, it means they've done something wrong. So we need to think out of the box. And out of the box means the regulators should think as technologists and as designers, and the designers, because the designers already think as regulators. They already done that. They know they have to capture their markets. Similarly, when you're a scientist, and that was another thing which I was trying to highlight, is that these are considerations which you need to have ingrained into your research. And this is how you should be able to structure your technology so that you allow the transparency that is required. Transparency being one of the things, explicability, explainability, and predictability. Finally, last but not least, I think this is an issue which we are going to keep finding as technology and regulation, they become so immersed. It's a fundamental, again, it's a big question. It's not just a practical one. It's a much bigger question of how we deal with democracy today.
Thanks. The Q&A has picked up on questions. Taking them by order, I'll go to Alessia's question. Then Natasha, you raised your hand. You wanted to ask something, or was it a comment on this discussion?
It was just a comment.
Okay,
it's
please.
All right, we can move on.
No, if it's a comment on this discussion, say it now, and then we'll go to the questions. Natasha.
Can you hear?
Yes, now we can. Do you have a comment on this discussion, or should I go to one of the questions?
It's not good.
You cannot hear.
Now I can hear.
Okay, what was your comment?
I just wanted to reiterate. I hear the discussion about the design versus application. I just want to say that the issue is extremely complex because we need to consider the whole value chain, from the idea and algorithm all the way to the product or service. And along the line, there are so many things that happen. It's not just plainly design. It's not just plainly application. But it is absolutely critical to talk about the responsibility chain. So we need to look at very carefully the decision-making process of where and when components was introduced and how it affected. I just want to say, I agree
Sure.
on both sides are there, but I think there is still complexity that needs to be put on the table. However, policymakers need to make it simple. I'm sorry, without going into depth, it's not going to get us in the good place.
Sure. And every path, every step of the way, there are biases that can be introduced, and,
Yes.
and you need to worry about that. Okay, Alessia's question: explainable AI, explicable AI. How do you think they relate to openness? Can these features be used to assess at least partly the trustworthiness? Who wants to pick this one up? Natasha, go ahead.
I'm happy to comment on this, because there is so much pressure now on the creators of AI to make this simple and understandable to everybody who is using it. Now, imagine if every doctor on earth, say, or every surgeon need to explain to you how they're operating on your heart, and to a detail that actually they will be responsible to other professions in that field. So we need to clearly understand here who needs to understand and what needs to be explainable to whom. I would just say that, again, we need to look at the context in detail. Even if I give you now an application that takes you to, say, predicts the traffic for you when you're going, say, to London, say, from Nottingham, you will learn how to use that application, because you will see whether what application is showing you actually corresponds to the reality. And then there is this AI going in my head, understanding how the AI on my mobile phone works with reality. So I'm in a constant assessment. So my point here is that explaining something doesn't have to be at the algorithm level. It is on a utilization level. And unfortunately, that goes all the way along. Even I, as a mathematician, I need to see how the code works and see how the code is going to act into things that I understand. So I'm worried that demanding now explicability is actually a complex problem that needs to be done by clarity on who needs to understand what. Do we put a place on understanding the application, or do you want to know the theory that goes behind? And I'll stop here and let others pick up.
Sure, sure. Anyone else who wants to chime in on this question before going to the next one? Yeah, Prodrome.
I agree with Natasha, and in terms of how you deal with this, I mean that there are some very practical limits in how you introduce explicability and explainability. And I would add, Natasha, the predictability problem as well, because this is also something which is expected sometimes. And the thing is that we are having a transition here. We have over almost 40 years now, almost 40 years of open source software since 1983, and we have another 20 years of public sector information, and we have 60 or 70 years of open government. So we are used in at least in the perception and the illusion of openness in relation to governmental decisions, source code, data, and when you bring this new thing. We do this transition as if there is no categorical difference, but there is. So the first point would be, I go back to Natasha's point, what do we define as AI and what do we want to say by open? And what would be sufficient for our policy objectives? And I think that's also what the parliament tries to do. And I think that's where we should be focusing.
Great, great. So let me move to the next question by Gabriela. What is development in mitigating the risk related to with AI? I'm just reading as it is. Can it be mitigated at all? I mean, producing false scientific texts and similar things like that. Is there a way to mitigate such kind of risks?
I'm willing to take a first stab at that.
Okay, Alex, please go ahead.
I mean, the first answer is I don't know of anybody doing work right now necessarily on mitigating risks in the case of scientific texts, but there is a lot of work going on in the spread of disinformation in general and false news, and especially when you start taking some of these large language models like GPT-3 to generate news stories, things that look very much like a news story. So what are the mechanisms that are in place then to start validating in more or less real time things that are emerging? So that work is ongoing and an interesting area of study. I think it becomes much harder in the case of scientific texts because by their very nature, they are talking about novel research. So there is not ground truth necessarily against which to evaluate a given scientific text. This is why we have peer review. This is why the scientific endeavor is an ongoing conversation of people making claims and other people validating those claims. So I think it would be a very hard proposition to think about, an interesting one, but a hard proposition to think about applications of AI to counter in sort of an adversarial way the use of AI for falsifying information in that area.
Yeah, that would be fantastic if we had that. Yeah, Natasha, please.
Yes. So just to continue on the example that Alex mentioned about misinformation, I think there may be a time now for publishers to come back, because what has happened is because of the internet and ability of everybody to publish anything and everybody access to read it, we have the publishers, the recognized publishing routes were sort of challenged because they could not prove, or they have not seen as added values. However, my feeling now is that the only way we can mitigate the risks from misinformation now is to go back to the trusted publishing sites. Now, we have now gone through the phase of where we have had a dispersion. How is it going to go back to trusted resources? This is going to be very interesting. But I have faith that that in fact the demand and the supply will then find the sweet spot. The only question is going to be whether the internet that promised information for free to all will stand being challenged on misinformation to all, you see.
I don't think the publishers ever went away though, Natasha.
Yes.
I know. It's just we citizens challenged it.
Yes. Okay. Yes, Mihaly, a short one because there are two more questions that are fascinating to answer. Yes, go ahead.
Very short one. There is also the issue of deepfakes associated with misinformation, which hasn't been addressed separately in the frame of the regulation. So there is going to be, I think, a discussion starting in a few weeks' time about whether we need a special act on deepfakes, because this is an application of dystopian application of AI, which may undermine the stability of our democracies in many ways, as we have seen the latest political campaigns both in the US and the UK.
Great. Going to the next question, which is for you, Mihaly, and a very interesting one. I have a question for Mihaly. This is from Samuel, as he touched on this issue very briefly. How desirable is it for legal personality to be granted to autonomous AI software systems, especially within the context of open research? So for a software to be granted a legal personality.
Oof, that's a discussion, that's a question that we have been trying to answer for the last 4 years. Simply because, as I said, it was introduced in that resolution. The official line is that we don't discuss about this type of personalities. It's too early. We're still in the era of weak AI. There are no such developed applications that can operate in an autonomous manner to the extent that we can grant them a legal personality. So, technologically speaking, I don't think we're at the stage where we can, treat this application as an object of special regulatory attention. However, the issue is being discussed right now in the frame of the algorithmic decision making, whether certain algorithms, the so-called self-learning algorithms, need to be treated separately as a high-risk application, as something that develops its own life form, and whether that specific aspect requires a different way of attributing responsibility and liability in civil terms.
Wow.
But I'll stop here.
Okay.
It's a very tricky issue, a very sensitive issue, and that is something that the Parliament was also kind of accused of trying to sideline the responsibility of the producer, of the developer, and trying to kind of pass the buck to the robot itself somehow, or to the autonomous car itself.
Rodrome?
It is indeed a very tricky issue, but I have to for any lawyer that attends this event, I would say that these are questions that like 20 or 30 years ago we would have about corporate criminal responsibility, about whether a legal entity can have criminal responsibility. So we shouldn't see it as an anthropomorphic question, but we should put it as what it is technically speaking, which is precisely what Michalis said with his last sentence. It's a question of how you handle liability, the question of how you handle responsibility. So it's not a human rights issue. It could be, it has been such a discussion as well, but it's mostly a liability, a property question, a responsibility question in ethical sense, and that's how it is framed. So just to make it very clear to our audience, what is the discussion that Michalis is talking about? Thank you.
Yeah, we're at the end, but I got permission to eat a few minutes from the break, and if the panelists could bear with me. We have one last question. I have 100 questions, but I won't ask them. But one last in the Q&A panel. Is not open science plus AI simply feeding our capitalist economies in a time when the focus should be on sustainability? Quick answers to this. So consumerism versus, I assume that capitalist, that's the key thing here as the opposite of sustainability, consumerism. So does open science plus AI help consumerism versus sustainability? Any words of wisdom? Yeah, Natasha?
I actually, my first association with open data and open AI was in fact to help scientists. And so I'm a bit surprised with this question, but I can see that there may be truly a situation where organizations or entities, they have resources and they have ways of harvesting and benefiting from openness, could be actually corporates. But as I said, my first impression was, in fact, opening this up to those who don't have money and who can then have easier access.
Anyone else? Yes, Michaeli.
I'm trying to echo what the certain committees of the Parliament are now discussing, is that how we can use AI to serve, to meet the Sustainable Development Goals. So there is an attempt right now, political attempt to link these two frameworks, these two narratives, the Sustainable Development one with the technological one, and see whether AI for good can achieve some of these goals in a faster manner.
I will add that I think this is setting up a false dichotomy in the way that the question is framed here, and I think the question ought to be open science applied correctly. The openness of the scientific process ought to be something that leads towards more equity and inclusion and participation in the scientific endeavor, more transparency, and as well. AI and open science are things that I think can help solve some of the problems of sustainability if applied in that area.
And Prodrome?
Last but not least, first of all, I would invite Richard to attend tomorrow, same time, the panel we're going to have about the ethics of openness. So lots of questions there. So Richard, you have to be there. Second thing, when we think of AI as a proxy for what we call big tech, yes, it may be applicable, but that's, as Alex said, that's not what AI is about. And and also I would, following what Natasha said, the word simply doesn't fit in the sentence. There's nothing simple in relation to AI. And we can, of course, if we have open data, they're going to be extracted. It's our job to find how we share them ethically. It's our job to make sure that AI is going to be used for sustainability purposes and not just for profiteering. That's our goal.
I think with this question and all four of you giving really thoughtful answers is no better fitting ends to this panel. I want to really thank you all four, Natasha, Alex, Mihaly, Prodrome, for wonderful interventions and exciting answers. I also want to thank the audience for many important questions and provocative questions that led to this great discussion. Thank you very much, all of you, and let's hope in the time to come to make AI useful and help society move forward, give us the best fruits that it can. Thank you all. Thank you to the audience, and back. I think now is the time for break. Thank you. Bye-bye.
Bye.